Hello everyone, I'm Tan Hao and I'm from Group 9. Our project is identifying authorship of source code with neural networks. Next part is our team. Our project advisor is Dr. Wang Boyang. He's from Department of Electrical Engineering and Computer Science. The first team member is Li Rui. She is good at C++ and Python languages, and she's also familiar with Microsoft softwares. Another team member is Xu Jidong. He is familiar with C++ language, and he did well in the MATLAB and Microsoft softwares. The last team member is me, Tan Hao. I am familiar with C++ and C languages, and I also did well in MATLAB and Microsoft softwares. And all the team members are responsible for the group communications. The next part is the background of our project. About the problem, identifying the authorship of source code can be used in many applications, such as identifying the authors of malware plagiarism detection, tracing vulnerabilities of software, and so on. The problem can be formulated as a classification problem in machine learning. And the current solutions, according to some papers and researches we have found, we can build the neural networks with leveraging word embedding, such as word2vec, and long short-term memory networks to encode the source code and perform the classification. Next, welcome Li Rui to introduce the next part. Thank you.
I'm Li Rui. I will introduce the proposed solution and design plan for our project. We can regard the code authorship identification problem as a classification problem. Each code file will be classified with an authorship. From this flowchart, we can see the main four steps. First, we will use coding algorithm to encode each code file to get the input sequence with the word frequency as the input of the network. For a second step, we input the sequence into the network. In the training process, every weight from input layer to hidden layer, hidden layer to hidden layer, hidden layer to output layer will be trained, and we can get a weight sequence as the final output. For the third step, we use this output sequence to do classification to search for the authorship. And for the first step, the whole network needs to arrive the accuracy more than 85% over all training and testing dataset. And from this process, there are three main structures we need to use and build. The first part is the encoding algorithm TF-IDF, the term frequency inverse document frequency algorithm, which can transform the code file into a sequence. The second part is the main neural network structure, LSTM, long short-term memory, which is the kernel part of the whole project. The third part is the classifier to classify the output sequence to corresponding authorship. With all these three main structures, we can realize what we want to do for our project. This image illustrates the code network structure. In data processing, the TF-IDF can process these code files into sequences as the input to neural network. There are two RNN, the recurrent neural network layers, and two fully connected layers. Each two units on two layers are connected with trained weights. With enough training, we can get the output sequence, and with more training by more code files, we can get more accurate output and classification. So to realize better identification accuracy, we may increase the number of network layers from 2 to 3 in the future. The next part is about our design plan. To realize a neural network, I said before, we will use Python as our compiling language, and we will also use TensorFlow, Pandas, scikit-learn, and other basic packages to help us apply TF-IDF and build deep learning network. As for compiling environment, we will preliminarily train the network on personal PC as the information shown above in the table, and we will train the completed model on GPU with the access from Dr. Wang finally. For the training and testing dataset and scale, we listed all C++ files information from Google CodeJam from 2008 to 2016. We collected some code files randomly from them. Now, we are focusing on C++ files and their authors. We plan to train and test the model with 10 authors first, with all their files, and then for 20 authors in the next state. That's all for our proposed solution and design plan. Let's welcome Xu Jidong to introduce the next part of our presentation.
Hello everyone, I'm Xu Jidong, and I will introduce the following two parts for all of you guys. The first one is the responsibilities of each team member of Group 9. For Li Rui, she needs to collect training data and test the data, and she also needs to learn and apply LSTM algorithm and write encoding programs. Besides, she is responsible for communication with advisors and write reports. For me, Xu Jidong, I need to search for data and code from GitHub and Google Jam. Besides, I also need to study papers and algorithms such as RNN algorithms. Third, I need to write and design programs. Finally, I need to write reports and papers. For Tang Hao, he needs to search data and check the code. Then, he needs to learn and apply TF-IDF algorithms into our programs. So, he also needs to write reports and papers, and organize weekly meetings. Let's look at the next part. The progress so far and Gantt chart. So far, we have finished the following tasks. The first one is the background basic knowledge study. The next one is the study of principle and the structure of TF-IDF LSTM. Next is the preliminary completion of code implementation. The last one is the preliminary collection of training and testing datasets. The right-hand side is the picture of our program, and this is written by Python. Let's look at the Gantt chart. In the fall semester, we finished a lot of tasks, including the preparation and preliminary proposal. Then, we learned the network security and machine learning. Next, we study how to input data and vectors, and we spent 1.5 a month on this task. Then, we leverage source code by collecting training sets and testing sets. Then, we begin to build neural networks. For the next semester, we plan to build the neural networks from January. And then we will perform authorship identification from January 25th. about half a month, we will train the neural networks. About at the end of March, we will get the final results and write our papers. And we will finish our senior design at this time. Thank you for watching. That's all about.